So soil moisture monitoring is an important part of our irrigation water management in the Texas High Plains. Certainly we want to take advantage of all of the off-season and in-season precipitation, and one of the ways we do that is by storing it in the soil, thinking of the soil like a bank. But like a bank account, you need to know how much you've got in there and your rate of extraction so you can properly manage your irrigation on your crop. So with the Water Conservation Center, knowing that that's an important part of a management program, we've run the gamut of sensors of what we can look at and actually try to apply in a production field for water management. So across our experiments in corn and cotton in 2019, we've got aquaspy probes, we've got gypsum blocks that are spread throughout. Close by, our goal there is to ground truth those different sensors with what has become the standard in the area with gypsum blocks. We've got trellis probes that are installed. The trellis probe is essentially a watermark probe that's got telemetry tied in with it. We've got a METOS probe, which we've used before, and we've got Grow Guru probes that this is the first year we're using those, and hopefully we'll have some information to share with that. Right now we're standing by one of the aquaspy telemetry sites. All of these seem to be very effective. All of these seem to have some benefits. There's price point differences, and our goal is to assimilate all of that information we come in, see how useful the delivery systems are, and then give a report at the end of the year of which ones can be endorsed or which ones should be part of a production system. One other thing I'll add to that in terms of ground truthing, before we planted on either of these fields, we went and dug 8-foot deep backhoe pits and took a gravimetric sample where we measured the water content at every increment from 1 foot to 8 feet. We did that in the cotton and the corn, and then at harvest we'll come back and replicate that so we can have a true beginning and ending number so we can come up with an accurate number of what the water balance is. Now the reason that's important is most all of the probes and sensors we're looking at are relative. They don't have inch marks per se. They've got scales where you can approximate those, but in order for us to have true measurements, we're going to actually take these true measurements and then spread them across all of the sensors to see how reliable and consistent they are.